Water being pumped out of this underground mine in Preston County is being treated before it enters Canes Creek, part of the Deckers Creek Watershed. As part of its permit, the mining company is responsible for remediation of the water it produces. The water is chemically treated with lime, calcium hydroxide, to neutralize the acid and remove the iron and aluminum in the water before it's discharged safely downstream. But it's a different story in other parts of the watershed.
Of all of the sub-watersheds in the Deckers Creek watershed, Canes Creek was the most heavily contaminated, and Deckers Creek water quality above Canes Creek was good enough to support fish and macroinvertebrate life, where below Canes Creek there was no biological life, at least not until much farther downstream. Since treatment measures have taken place on Canes Creek, benthic macroinvertebrate and fish populations have actually rebounded in Deckers Creek.
Tim DeNicola is project manager for the Friends of Deckers Creek. The group was started in 1995 and works with the DEP and other agencies on cleanup projects throughout the watershed.
Funds are limited, and watershed groups such as Friends of Deckers Creek, we do what we can with what we have, and a lot of times it's treating smaller discharges, smaller amounts of contamination. Now, it all adds up. Every small project that's completed reduces that much more acidity, reduces that much more metals contamination. But to actually implement a full-scale treatment operation like this takes the kind of money that you typically find associated with the industry itself, not with the water remediation side of it.
Those smaller discharges typically are treated passively, like this project at Sandy Run. Water from an abandoned mine flows through a series of ponds. It's filtered through a layer of compost, which takes the oxygen out, and through a layer of limestone to neutralize the acid. With the oxygen gone, the iron turns into a form that doesn't coat the limestone. Properly maintained, there's enough limestone in the system to neutralize the water for decades.
We know that flushing these ponds helps them work for a longer time. To save some of the travel out to flush the ponds, 2 of them actually have automated flushing gizmos that flush them every week. The 3rd one doesn't, and we come and flush that manually about once a month. When we measure the water coming out of the end, it is neutral. There's no acidity in it whatsoever. And for half a year after this project, when we measured the water coming out of the dam, it also was neutral. And of course, that means that we not only neutralized this one, we neutralized enough in the whole watershed upstream of the dam to counteract whatever acidity was still coming in through the untreated tributary over there.
But this system of ponds takes up a lot of ground, and in some places that's just not a practical solution. Those situations call for a more active form of treatment. The Friends of Deckers Creek maintain this active dosing site, South Site Number 1. It's powered by water and mixes a measured amount of lime into the stream. It's one of 2 active dosers operated by the group. Limitations imposed by the terrain were one factor in choosing an active solution for this site. Chemistry was the other.
It's a small volume mine that's only partially flooded, which allows highly oxic conditions. In fact, the coal bed itself is maybe 20 feet below the land surface, and when mining engineers look at mine subsidence and mine fracturing, they often say that the subsidence and the fracturing patterns extend 300 feet over a mine seam. So when it's only 20 feet to the land surface, there's a high rate of recharge of groundwater and introduction of atmospheric oxygen into the mining environment, which causes greater dissolution of iron sulfide minerals and greater acidity and greater dissolution of clays and greater introduction of aluminum into the mine water. So ultimately you end up with highly oxygenated water with high concentrations of iron and aluminum because it's so shallow, because it's so oxygenated. And that may be why this mine discharge specifically was so severe.
In Preston County, I'm Erin Krillman for Environment Matters.